Hello everybody, in this one we're going to take a look at writing series for 2 to the x, 3 to the x, and 8 to the x in general. And the question is there some simple rule that you can use to find series for these? Well, the rule is to understand the fundamental relationship between e and the ln function. So let me remind you, and perhaps since it's been a while, I did talk about this in a previous video. So it says that e to the ln of a is a. And that is so exactly because the ln and the e functions are inverses. So a can be equivalently written as e to the ln of a. Once that is in place, then take a look. So for example, 2 to the x, let's write a series for this. This is equivalent to writing the following: e to the ln of 2, and the x goes in this position. I want to be clear here that the 2 here is the 2 from the base. The x is a separate value, and the exponent stays in that position right here. So now let's write a series. Use the same series as for e to the x. So in other words, this would be the summation here as n goes from 0 to positive infinity. And I'm going to simply say the following, that this is to the n over n factorial. And the pieces n and n factorial, those are from the basic e to the x series. The question is, what should we put inside the parentheses? What goes inside the parentheses is this part right here, whatever that part happens to be, together with the ln too. In other words, what this is telling us is that this right here, this is playing the role of x, that whole quantity. So here you're going to put ln 2 and then x in this position. That's all. Let's simplify this a little bit so it looks better, more clean mathematically. So n goes from 0 to positive infinity, and you distribute the n over to the ln, the x. So it's going to give you now ln, for example, of to the n of 2, and then x to the n over n factorial. That's how you do that one. So this series in yellow represents the series for 2 to the x. Following the same reasoning, let's do one more for practice. So imagine I gave you e, and then I would have ln of 3 and then x. So we write the series using the series for e, so n from 0. Put here ln of 3x over n factorial. This whole thing is raised to the n. And then up here there's positive infinity. Then you just simplify it a little bit. So let's see here. Summation as n goes from 0 to positive infinity of ln of 3 to the n, x to the n over n factorial. And based on these patterns, then you can write the general rule. For example, when you have a in the base. So let's write that out here. First of all, I'm going to write this as e to the ln a x. And then I plug into the basic patterns. I'm going to have as n goes from 0 towards positive infinity. Now this whole thing is what gets stuck in there. So it's going to be ln of a times x. So that's going to give me now, within parentheses, ln a x raised to the n over n factorial. Let me just clean that up a little bit. So summation from n0 to positive infinity, ln like that, x over n factorial, and that's an n on the x. And that's how you can make use of the basic natural base function e and get a series for things like a to the x, where a is a number like 2.58 or 1.98, whatever it happens to be. You can rewrite in terms of e. Thanks so much for watching.